are. All right. So yesterday we learned about a median, and that is a line segment in a triangle that we know goes from a vertex to a midpoint. All right. So now we're going to learn about two new line segments that do other things. So let's focus our attention first on altitudes. Okay. So an altitude, I'll first start by giving you the definition, and then I'll draw you some pictures. So I got to zoom out a smidge. All right. Altitudes in triangles. Well, actually, before I do that, what's the word, when you hear the word altitude, what do you think of? Just in like everyday conversation, if you hear altitude, what does that mean?
Going up or the height of something.
What'd you say?
Going up or the height of something.
Yes, height. Right? So if you are flying in a plane, they talk about the altitude, and that's how high you're flying. So altitude, I really want you to associate that word with the word height, okay? Altitudes in triangles are basically the height of a triangle. Now, here's what it has to do, okay? So they go from a vertex and drop perpendicularly to the opposite side. Okay, so let me give you a minute to jot that down, and then we'll look at some pictures. Altitudes in triangles, the height of a triangle. They go from a vertex and drop perpendicularly to the opposite side. And they're going to look a little bit different depending on what kind of triangle you're looking at and what vertex you are dropping down from. But every triangle has a height or an altitude, I should say. You can draw an altitude from any vertex in any triangle. And I'm going to show you how. All right, so let's look at some drawings. We'll just start off with our basic acute triangle. So go ahead and sketch yourself any old acute triangle, doesn't really matter. So the altitude, you're going to start at any vertex. It's just easy to draw from the top one here. I'll use my red pen. So I'm just going to pick a vertex to start at, and then I'm just going to drop the line perpendicular down to the other side, just straight down as best I can, though I kind of messed that up. And I'm also, it's very important that you mark it as perpendicular, because if you don't mark it as perpendicular, then I don't know that it is, right? So that right there, that red line that we just drew, that would be referred to as an altitude. Okay, so let me come in here and write that. All right, let me draw you another one. Maybe you have something like this. And then I could do the same thing if I just take that vertex and I'm just going to drop it straight down. So here is another altitude. So you can see that this is very different from a median. The median, they would start at the same point, but the median would go to somewhere about here because it's got to go to the midpoint of that other side. And the altitude doesn't care where it lands. It just has to be perpendicular. All right, so here is another altitude. Oops, I spelled altitude wrong. Altitude. Here we go. Now the altitude doesn't always have to be drawn vertically up and down like this. So let me draw you another triangle and we can drop it from another location. I'm going to draw you an obtuse triangle here. Oh, you know what? I don't want that one. Sorry. I'm going to change it a little bit. Sorry. Okay. Let's get this one in view. All right, so here is just some random obtuse triangle. And if I wanted to, you'll notice, so I was just saying that they don't always just go straight up and down. If I wanted to draw the altitude, let's say from this one, if you draw it straight up and down, don't write this, but just look. If I did that, there's no way that that's perpendicular right there. So you can't just, I don't want you thinking that you just drop it straight down. You don't, you drop it perpendicularly to the other side. So in this case, it's gonna look actually a lot more, oops. It's gonna look like this. If I'm starting here and I wanna be perpendicular to this side, it's gonna drop like that. So I make the 90-degree angle there. Okay. Now, things are going to look a lot different in a right triangle. So let me draw you a right triangle and let's take a look at what might happen there. All right, so let's go ahead and mark that this is a right triangle. All right, so what happens if I'm going to try and draw an altitude from this vertex? So remember what my rules are. I want to drop perpendicularly to the other side. If I do that, if I drop perpendicularly to the other side, it's going to be this side of the triangle. That's okay. So that can totally happen. So if you have a right triangle, it is entirely possible for the side of the triangle to be the altitude. Isn't that something? So you can have an altitude that is in fact one of the sides of the triangle if you have a right triangle. Now, is every altitude in every right triangle one of the sides? No, because you could have, I'm going to redraw the same triangle and just draw an altitude from a different spot. So if I recopy this triangle, best I can, my new pens are coming. When are they coming? Either today or tomorrow, I think. I don't know. I'm very excited about them. Anyway, so if I wanted to, what if I wanted to start my altitude at this vertex? Because you should be able to draw it from any vertex you want. So if I wanted to do it from that one, I've got to drop perpendicular to this other side. So it could look like this, right? Where there's my right angle. So that is possible. You can still have the altitude on the inside, but it is possible to have it as one of the sides of the triangle. And now, the last really weird case. Are you ready for this one? Watch what happens here. I'm gonna come over here and I'm gonna draw you an obtuse triangle. So what happens if I wanted to, you ready for this? check this out. What if I want to draw an altitude from this vertex? How in the world? It's got to be perpendicular to this side. So here's one problem. Let me grab one of my thingies here. Oh dear. All right, so pretend that this orange stick was my altitude, right? So if I was trying to draw this, if it goes from that point, there's no way if I draw it like this, it's never gonna, this orange stick is not gonna be perpendicular to the bottom here. The only way to get this orange stick to be perpendicular is if it's all the way over here. So that means you can have altitudes outside the triangle. What? Yes. So this is usually how we draw it. Okay. So first of all, I need to draw perpendicular, but the only way to make that happen is if this side was a little bit longer. So if it's going to happen outside the triangle, we usually just extend one of the sides, and it's usually just a dotted line that we use to just make that one side longer. And then I can go ahead and drop the perpendicular like that. So it can happen that you have an altitude outside the triangle altogether. All right, so there's my altitude this time. Isn't that interesting? But notice in every single example that we've drawn, all of them, whoops, wrong way. Every time we draw an altitude, we mark it as perpendicular. That's crucial. So see how we put the little box in every single one? If you have a diagram without that little box, you don't know that that thing's an altitude. You can't assume that it is. You would have no idea unless there was other information that led you there. Okay, so those are altitudes. And then all we have to talk about is perpendicular bisectors. Okay, and they are kind of neat because their name tells you exactly what they are. So I'm actually going to turn the page and we will talk perpendicular bisectors. Let me just wipe this page down a little bit. It's got some old marks still on it. Any questions so far? You guys doing all right? We're feeling okay on a Tuesday in December? I can't believe it's December already. I mean, yes, I can, because it feels like we've been in this year for like a decade. But anyway. All right, so perpendicular bisectors. The name says it all. So these are going to be lines or segments or rays, it could be even. It's just going to be something that is perpendicular to a segment or a side of a triangle, and it bisects that side as well, okay? So this is a, let's say, line, segment, or ray. Sorry, zoom out a smidge. Line, segment, or ray that is perpendicular to a side at its midpoint. That's the bisect part, right? Because a midpoint bisects a side into two congruent parts. So you have to be able to verify that both things are happening in order to have a perpendicular bisector. And this is the first line that we've talked about that doesn't necessarily have to touch a vertex. All the other ones had to start at a vertex and then go somewhere. This one, maybe it hits a vertex, maybe it doesn't. They don't necessarily have to. So let's look at some pictures. I'll just start off with a triangle like this. So if I want to draw in a perpendicular bisector, you can do it for any of the three sides. It doesn't matter which one. I'm just going to focus on the bottom one because it's easy. So what it has to do, I'm going to eyeball the midpoint, and I'm going to mark it so that I know that that point is the midpoint for sure. Okay. So what my perpendicular bisector has to do is it has to be a line that comes through and it passes through this midpoint, but it also has to be perpendicular. So it can't just be any old line, right? So again, imagine if it was this orange line here. So here's a line that hits at the midpoint, but it's not perpendicular to that bottom side, right? So here's another one, hits at that midpoint, but it's not perpendicular to the bottom. It's got to do both. It's got to be perpendicular to the bottom and bisect. I shouldn't be saying bottom. Whichever side is getting cut in half, it has to be perpendicular to that same side, because it's not always going to be the bottom. But in this case, it is. So my perpendicular bisector would have to look something like this. So it's got to be some line or segment or ray, and it's got to be perpendicular right there. And it's got to pass through that midpoint. So the name says it all. Perpendicular, check. Bisector, check. All right, so this line we would refer to as a perpendicular bisector. Okay, let's take a look at a different type of triangle and what it might look like. So what if I had, I don't know, that's actually kind of the same triangle. Hold on. I'm gonna make it obtuse. All right, so say I had something like this. If I wanted to draw in the perpendicular bisector, let's say of this side here, sometimes it's easier to turn your paper. So I'm going to first eyeball about where the midpoint is. About there. I'm going to mark these two sides congruent. And then my perpendicular bisector would have to pass through this midpoint at a 90-degree angle. There we go. So, and I have to mark it as 90. So it's got to be perpendicular to one side, and the side that it's perpendicular has to be the one that it's cutting in half. So it needs both of those requirements in order to be a perpendicular bisector. Okay, let me draw you another one. Remember I said a few minutes ago, these don't have to, notice these two that I drew, they don't touch a vertex of the triangle at all. Can they? Yes. So let me draw you one where it does just so happen to. So if I had a triangle like this one, and I went ahead and I found, so let's eyeball the middle. I'm going to mark these two sides congruent, and then it's got to be perpendicular. So in this case, it just so happens to hit that vertex. Let me go ahead and mark it as perpendicular. So that can happen. This particular one right here is actually a whole bunch of different things. Isn't this thing, sure, it's a perpendicular bisector. It's perpendicular and it bisects. But isn't this thing also an altitude? It happens to be going from a vertex and it's perpendicular to the other side. That's cool. That thing is also an altitude. But remember what we learned yesterday. Medians go from a vertex to a midpoint. In this particular triangle, This one line that I drew is all of those things. So this one happens to be a median and an altitude and a perpendicular bisector. This one thing just so happens to be them all. How interesting. I wonder what type of triangle this must be. I'll tell you, it's an isosceles. If you have an isosceles or an equilateral triangle, your one of these segments drawn from the right vertex can be all of them. Isn't that fascinating? So anyway, guys, all you need to do on your homework tonight is identify which thing you have. So I'm done with the notes. Let me hop on over. I think it's on Delta today. Is it? Yes, today is on Delta. So let me stop this share. I'm going to hop over there and I'll just do a couple of them with you real quick. Are you guys still there? You're so quiet today. Everybody's there? You're alive? Okay, so here we go. This one you will notice is one of those ones where you don't get to do as many as you want. You only get I had to make them all. So you don't get to just keep answering as many as you want until you get them right. So you only have this, I think there's, I don't know, how many is there, 15-ish? Oh dear. So you're gonna click on one and it's going to give you some picture. And I'm always going to be asking you about segment AB, which should show up kind of in blue here. So you have these 4 choices really. Is that thing a median? So remember, to be a median, it has to go from a vertex to a midpoint. Does this do that? From a vertex to a midpoint? No, this is not touching a vertex, line AB. So median's out. And altitude has to go from a vertex perpendicular to the other side. It's perpendicular, but it doesn't start at a vertex, so it can't be an altitude. However, a perpendicular bisector has to be perpendicular to a side and bisect that same side, and it does do that. So this first one's just going to be a perpendicular bisector. Okay, let's try another one. So here, all right, I have segment AB again, and it's always the same choices. So you can just walk through one by one. Median has to go from a vertex to a midpoint. Does this do that? You bet it does. Vertex to a midpoint. So this thing is just a median. And okay, here's one. So that's not a median because it starts at a vertex, but I have no indication that it's going to a midpoint, right? I have no idea if these 2 pieces down here are equal. So I can't say median. Could I say altitude? Is it going from a vertex perpendicular to the other side? Yeah, it is. I can't say perpendicular bisector because, again, I don't know that that other side's being bisected. So I've got to go with altitude. All right. And I will tell you right now, there are going to be some that are, let's see if the next one is. No. I'm going to try to find one that's. No. Trying to find one that's none. Oh, here we go. So this particular thing, this is a special line segment, but it's not one that we have talked about anytime recently, at least. So this thing is not a median. It does start at a vertex, but I don't know that it's going to the midpoint of the other side. So I can't say that. Altitude, it's not perpendicular to the other side, so I can't do that. So if it's not perpendicular, I certainly can't pick perpendicular bisector. So for today, I'm going to have to pick none of these. All right. So if you happen to know what that is, we have mentioned this thing before. So if you know, then good. We're actually going to talk about those tomorrow. But anyway, that is your homework. It should be relatively fast.